A sea breeze or onshore breeze is a gentle wind that develops over bodies of water near land due to differences in air pressure created by their different heat capacity. It is a common occurrence along coasts during the morning as solar radiation heats the land more quickly than the water. A land breeze or offshore breeze is the reverse effect, caused by land cooling more quickly than water in the evening. The sea breeze dissipates and the wind flows from the land towards the sea. Both are important factors in coastal regions' prevailing winds. Offshore wind refers more generally to any wind over open water. Offshore wind farms take advantage of the higher wind speeds available over the sea, but are usually placed near coasts to reduce costs and to take advantage of daily flows of sea and land breezes. Nearshore wind farms are those closest to land, while others are further out to sea. Cause: the sea has a greater heat capacity than land and can therefore absorb more heat than the land, so the surface of the sea warms up more slowly than the land's surface. As the temperature of the surface of the land rises, the land heats the air above it by conduction. The warm air is less dense and so it rises. This rising air over the land lowers the sea level pressure by about 0.2% or 2 millibars. The cooler air above the sea, now with higher sea level pressure, flows towards the land into the lower pressure, creating a cooler breeze near the coast. The strength of the sea breeze is directly proportional to the temperature difference between the land and the sea. If an offshore wind is occurring, however, that is greater than 8 knots and opposing the direction of a possible sea breeze, the sea breeze is not likely to develop. Effects: a sea breeze front is a weather front created by a sea breeze, also known as a convergence zone. The cold air from the sea meets the warmer air from the land and creates a boundary like a shallow cold front. When powerful, this front creates cumulus clouds, and if the air is humid and unstable, cumulonimbus clouds. The front can sometimes trigger thunderstorms. If the flow aloft is aligned with the direction of the sea breeze, places experiencing the sea breeze frontal passage will be benign, or fair, weather for the remainder of the day. At the front, warm air continues to flow upward and cold air continually moves in to replace it, and so the front moves progressively inland. Its speed depends on whether it is assisted or hampered by the prevailing wind, and the strength of the thermal contrast between land and sea. At night, the sea breeze usually changes to a land breeze, due to a reversal of the same mechanisms. Sea breezes in Florida. Thunderstorms caused by powerful sea breeze fronts frequently occur in Florida, a peninsula surrounded on both the east and west by the Atlantic Ocean and Gulf of Mexico, respectively. During the wet season, which typically lasts from June through September-October, any direction that the winds are blowing would always be off the water, thus making Florida the place most often struck by lightning in the United States, and one of the most on Earth. These storms also can produce significant hail due to the tremendous updraft it causes in the atmosphere, especially during times when the upper atmosphere is cooler, such as during the spring or fall. On calm summer afternoons with little prevailing wind, sea breezes from both coasts may collide in the middle, creating especially severe storms down the center of the state. These thunderstorms can drift towards either the west or east coast depending on the relative strengths of the sea breezes, and sometimes survive to move out over the water at night, creating spectacular cloud-to-cloud lightning shows for hours after sunset. Land breeze. At night, the land cools off faster than the ocean due to differences in their heat capacity, which forces the dying of the daytime sea breeze. If the land cools below that of the adjacent sea surface temperature, the pressure over the water will be lower than that of the land, setting up a land breeze as long as the environmental surface wind pattern is not strong enough to oppose it. If there is sufficient moisture and instability available, the land breeze can cause showers or even thunderstorms over the water. Overnight thunderstorm development offshore due to the land breeze can be a good predictor for the activity on land the following day, as long as there are no expected changes to the weather pattern over the following 12–24 hours. This is mainly because the strength of the land breeze is weaker than the sea breeze. The land breeze will die once the land warms up again the next morning. See also, Fremantle Doctor, the local name for the sea breeze in and around Perth, Western Australia, mountain breeze and valley breeze. References. External links: Sea and land breezes.